Okay, so here we are. We're going to look at number 6 first. And 6 says basically we're looking for the net gravitational force on the central sphere. So the net gravitational force on M5. Um, we know the mass of everything. We know the distance of everything. So this is just a pretty simple plug and chug. But the trickier thing here is that we have 4 different objects pulling or pushing on it. So M1, which is 5 grams, and M4, which is 5 grams, uh, those are going to attract in exactly equal and opposite directions, right? Because R is the same and M is the same for each of those. Those cancel out. That's a nice thing. So really all we care about is what effect M2 and M3 have. M2 is 3 grams and what's M3? 1 gram. Obviously, we're going to convert those to kilograms, right? And then M2 is going to pull this way. M3 is going to pull toward it slightly less. So that's going to be a subtraction, a vector subtraction problem. The net force then is going to be basically something like this, the blue vector here. That's going to be our net force. So it's really going to be using M2, M5 over R squared minus G M3, M5 over R squared. The R is the same in each case. That R is just the distance. Do it in purple here. This distance here. Each of them is the same. If we want to figure out what that is, we could just make a right triangle here. We know that 20 centimeters is the edge of each square, or each side of the square. So that's going to be 10 centimeters here, 10 there. And so this should be radical 2, 10, right? Oops. Radical 2 times 10. That's in centimeters. Obviously, we'll convert that to meters. And you can pretty much go from there. Not too hard. The next one we're going to look at is number 13. Getting a little bit trickier here, but not terrible. So we have a sphere. This big guy here is a sphere, and it's been hollowed out. So it's got a chunk of it that's been subtracted. So we saw an example sort of like that with a center of mass problem recently. This won't be horribly difficult, really. So let's see. We know that the total mass was 2.95 kilograms before we hollowed it out. So we're gonna basically treat this as if we had that mass 2.95 kilograms pulling on this other mass, little m, which is 0.431 from a known distance, right? That distance, where are we here? Right here, 9 centimeters, so 0.09 meters, right? So we'll figure out what that net force is first, and then we can subtract out what this little guy, when we took it out from the big one, how much we lost, right? So what force was that contributing? Keeping in mind that the distance is no longer 9 centimeters. It's going to be a little bit less, right? The 9 centimeters was would have been from here, from this location, the center of the big sphere. So you can figure that out. And then your total force, F net, is going to be, let me come back up here. Let's call this F1, and this is F2. F net is going to be basically the difference, right? So F1 minus F2. Okay, that's really all you've got to do there. Okay, let me know if you have any questions on those.